Hello to everyone. I'm Marco Lorenzi. I'm an Inria researcher in the Inria Center of Sofia Antipolis. My research is on the development of research methods to analyze biomedical data. So we work with the hospital, we work with healthcare data information. And we work with what we call today AI models. And so the typical paradigm for developing AI is to gather large collection of data, because we know that the accuracy and the flexibility, expressivity of AI model directly depends on the quality of the training data. So either we need to gather large repositories of a collection of complex data to train our model. This is a challenge per se, because usually healthcare data are hosted in hospitals, in healthcare institutions, so they are siloed, and they are highly secure due to the sensitive information of this, sensitive nature of this kind of information. And it's extremely complex, actually, to share and gather all this data across different institutions, across the national level, or even worse, at the international level today, in the same repository, in the same server for doing research. This is because of regulation, this is because of different regulation, heterogeneity, complexity, laws, ethical aspects. So this is the reason why the typical paradigm of machine learning of AI for the analysis of data, which is gathering data to a central location, then training a model, it doesn't work, doesn't apply. And this is something that started manifesting more and more with the advent of GDPR and European regulation. And this is what motivated to find alternative approaches, actually, to still benefits from collection of data that are provided by hospitals, but limiting the problem of sharing the data. And the solution is, instead of sharing the data, we can share knowledge extracted from the data. For example, we can share models. And this motivated this domain of research, which we call federated learning, or collaborative AI, in which basically every hospital is training some part of an AI model on its own, and then the results of this training, so the models, are shared and collected by a central entity, and then they are aggregated according to precise mathematical, statistical principle, according to some theories. There is research behind this. And we can give certain guarantees on the quality of what we are obtaining when we operate this procedure. So the model under central assumption is guaranteed to be equivalent of the model that we could have obtained if we could share actually the data and train a model directly on the shared data, so on the entire repositories. So this is a very powerful principle, very powerful concept that gave us a lot of attention and span actually in research and in industry for this kind of application. So the idea is to have a network of hospitals, which are called nodes, perhaps, and a central server that shares some parameters for a task, for a model that has to be trained. Every node performs the training task, and then they share back their results. These results are aggregated. This operation is perhaps iterated to guarantee some convergence, so it's an optimization scheme, and then we obtain the global model. And this model should be robust and should have all the good properties of a model that has seen all the data, without ever sharing the data. So we definitely address a problem of governance, because every hospital has the guarantee that data doesn't go out from the premises, and to some extent also privacy. So for this reason, there has been a lot of research, a lot of interest in terms of publication over time for this principle. And so there is a lot of research, as you can imagine, methodology that can be developed, but there is a lot of deployment and real-world exploitation that this paradigm is opening. So for this reason, there is a lot of interest from different institutions, academic, at the world level, and also important actors from the industrial world, among which Intel, NVIDIA, that they've been proposing libraries and software and frameworks to actually deploy this distributed optimization principle in real life. So if you will take one of these framework, this software, it will apply to the hospital level. So you will go to a hospital and say, okay, just install this, and let's train together our AI. This will not work, actually. And this is the big problem we are dealing with as a also researcher. Because an hospital network has a lot of complexity and constraints that we don't face when we deal with other kind of data, other kind of nodes of actors. So there are regulation about, and strict regulation enforced when it requires to enter to hospital networks, on the kind of communication, of the privacy guarantees. There is a huge problem of heterogeneity, actually. Hospitals adopt different practice for storing the data, for acquiring the data, and when we put together models that have seen this different data, the model cannot talk between each other because they have been trained on different data structure also, and data with different kind of heterogeneity, also statistical. So this is a big problem. There is a problem of governance. Putting together hospital and collaborating is not straightforward. There's a problem of ethics. There is a problem of IP, who owns the results at the end. And so we need to deal with also data protection officer. We need to homologate for security guarantees all of this infrastructure. And we need also, and with this what is most stringent, is the participation of the hospital in terms of their own resources. They need to be able to train a model. So it means that they need infrastructure, and they need also personnel that is on their side that takes care of running a model. And this is not straightforward. Hospitals are overwhelmed by many other tasks, and doing AI is definitely not among the principal tasks that they have to perform to care patients. So they need resources as well. So all of this defines a framework which is extremely complicated and fragile. And that's where actually at Inria, for example, we are dedicated to do research and also support all hospital and care institutions with the initiative that we call FedBiomed. So this is a software framework that we developed with the hospital. So it's we have a team which is embedded also in the hospital premises that is developing all the technologies that serve to solve all these blocking points that I mentioned before. So we deal a lot with the problem of security, to the problem of giving control, so addressing problem of governance on what we can do with infrastructure, which kind of control the hospital have, on which kind of training can be done, and usability, because we want this to be a powerful research tool. And so this is community-driven. So all of this is done by a team of engineers and in collaboration with a security officer. So there are different academic and also industrial partners that collaborate in this joint effort. So it is a truly interdisciplinary work that we are doing. And in the remaining time, I will give you just an overview of what it means, actually, having this kind of infrastructure. So we have this star-shaped network. We have some server, which could be hosted anywhere. And then we have the set of hospitals. So this, in principle, is a communication framework. So we have requests that are sent, and hospital can accept or reject this request of performing some operation, collecting the results, and sharing the results to then be aggregated by the server. And so there is particular attention that has to be dealt with the aspect of data management. So how we plug together different kind of data and different kind of all the subtlety of what is a machine learning model. So the model itself, how we deploy it, how we access the data, how we aggregate the different models together, how we enforce some privacy guarantees in all of this. So this is what we call a strategy that is basically a little set of instructions that is shared between all the participants. And this is applied to data formats that can be extremely heterogeneous. We can talk about health record, medical images, signals, and so on. And all of this should be actually something that we can request and access and explore at the central level to see which hospital is able to participate, to join actually the training, and all of these respecting privacy principles. So security is a big aspect because there has been research that has shown that there are many, many things that can go wrong in federated learning when we share the models, because sharing a model, sharing model parameters is not an absolute guarantee of the fact that we are not leaking any sensitive information. There has been research that has shown that, for example, if we train a model on some abdomen, so this is a liver, yeah, I think this is a liver, so this is a body, this is a chest image on this section, and we have a model that has been trained on that, and there is some information about the pathology, and just by accessing the model parameter, we are able to reconstruct somehow the data that originated that model, that was used to train the model. And this can leak actually some sensitive information about the pathological status of a patient. So we need to protect also the parameter. Just sharing parameter is not enough to have an absolute guarantee of privacy. because this can be leaked, can be captured by someone that is listening, for example, to the conversation that is in the network, and used for malicious purposes. And for this reason, there are different levels of security that must be ensured to be able to deploy this infrastructure in hospital. The first one is the low-level data flow. We need to guarantee that the flow respects only certain directions. For example, we want just to have outbound connection from the hospital. So everything has to be encapsulated in secure network, so the VPN. So either like an entire network, but also server-client communication. And then we have control. So hospital must be able to see which kind of code, which kind of model is executed on their machines, and be able actually to just drop from the study if they believe that the model doesn't respect some of the constraints that they want to put, for example, on how they access the data, what they extract from the data. So there is this sort of whitelisting procedure that must be enabled for the hospital. And then there is what we call machine learning, or privacy-preserving machine learning measures that can be ensured. So we can also train the model in a way that we can guarantee that the model will be secured. Secure in which sense? For example, we can use technologies like differential privacy that consist in perturbing the training routine, so the weights of the model, in a way that somehow we obscure actually the sensitive information by the noise. So we give some guarantees that if there was some sensitive information that was used to train the model, that will not be distinguishable after we apply the noise on the parameters. So it's some way to give some guarantee on the protection on individual patients that contribute actually to this training. Other kind of security measures could be, for example, what we call secure aggregation. So in this case, we don't want to disclose the entire model. So we want to encrypt actually the model, but not encrypt in a way that can be still useful to perform the aggregation, so to collaborate together between hospitals. And here there is a set of technologies that can come into help, among which multi-party computation or homomorphic encryption. These are methodologies that ensure that we can perform mathematical operation on encrypted objects. So we can share model parameters which are encrypted. And for example, if we have to compute an average, we know that we can still do that on the encrypted material. And then the results actually can be decrypted safely. And so we rebuild what we call the global model of federated learning. So this is an additional privacy guarantees that ensures that if I leak the models, no one will be able to access them unless they don't have the private key that was used to encrypt the model. So all of this make an ecosystem which is spans from machine learning, security, health data, management, and you can see how like a multidisciplinary effort is to do actually federated learning in the real world. And there are also, on the top of that, ethical and legal questions that have been raised, and we are also discussing with specialists in the ethics domain, in the legal domain. So, for example, who controls the executions, and who can say something about what can be done or not? Well, who holds the responsibility once a collective infrastructure like this is deployed? If something goes wrong, who owns it, actually? How to remunerate participants in terms of the contribution they make? Hospital that might not give any contribution because their data is not relevant, and other hospitals that can contribute a lot because they have a large data set and very representative. Who is owner the results, so the problem of intellectual property. And and then, well, there are also some research aspects like machine learning. Can we actually, if someone wants to drop from a federated network, can we actually remove what they've been contributing in terms of information on the model parameter? So this is what something is called today machine unlearning, so going back from the learning procedure. And just to say that this is our flagship application that we have currently here in France, which is led by Professor Olivier Ambert of Saint-Antoine-la-Cassagne in Nice, and is basically federating the infrastructure of hospital of the Unicancer Consortium for performing federated learning for lung cancer image analysis, so for detecting response to immunotherapy, for the analysis of lung cancer through deep learning. And you can see here, this is a figure. So this shows the federated, the real world, like federated training, how converge the aggregation process. The colors are different hospital. So in this case, we had the Hospital Institut Curie here in Paris, Saint-Henri Becquerel in Normandy, in Rouen, and the Saint-Antoine-la-Cassagne of Nice. So currently we are extending to the network of 10 hospitals. And this effort has been recently awarded, actually 1 week ago, 10 days ago, to the Prix Unicancer for Innovation of 2024. And we are very proud of that, of this recognition. So this effort will be ongoing in time, and we hope to create a permanent infrastructure that would allow all the hospitals to synchronize for every future study they will hold in artificial intelligence. And there are many other projects on which FedBiomed has been exploited. So these are academic projects from Horizon Europe to national project funded MNR, collaboration with the institutes worldwide. But we have also industrial collaboration that we are setting up currently. And so to conclude, federated learning is a key framework for a modern application of machine learning for respect of privacy and governance of data. So every time data is sensitive. Is an emerging technology, so it means that there is not a standard. There is a lot of efforts from different actors, academic and industrial, to develop technology for this. And everything is still work in progress, especially when it comes to healthcare data analysis, where actually data and all the heterogeneity I was mentioning before makes everything complex. Hello. Okay, which comes with challenges that I mentioned before. And so there is a huge problem of coordination between different actors. It's not just a machine learning problem. It's a much bigger problem. It's a societal, actually, effort that we have to make. So that requires a political vision in the long term from institutions. And there are the issues of security, bias, robustness of what we are. So there is still research that is needed to provide even better guarantees on the results that we are getting. And with this, I think I can conclude. Of course, Inria is actively involved in federated learning at both research level and what you've seen also translational level. So there are also courses, formation that Inria provides through Inria Academy, a little disclaimer. And also through FedBiomed, we are setting up a consortium. We very welcome very much anyone who's interested in participating, either as a community or also as an active, actually, participant contributor, as a, for example, industrial partners or academic partners, to develop together actually the roadmap and to also support the adoption of this framework in different initiatives. And this is everything. So thank you very much for your attention. Thank you.